Any of you ever watched Star Trek? I did. And one of the things that Mr. Spock, eyebrow raised, uh, brought out was something called EDIC, infinite diversity and infinite combination. And it was a wonderful philosophy of the Vulcans. Well, the key word that I want to focus on right now is the D in that, diversity. Diversity of signal is something that we observe in wireless because of multipath, right? Not plath. How about multipath? There we go. Multipath signals mean that that signal can follow different directions in order to get to a particular access point. Now, in our older, let's say 802.11g environments, I might configure an access point that has 1, 2 antenna. But in those older technologies, prior to 802.11n, we did not have any ability to utilize MIMO, multiple input, multiple output. In other words, you can only actually use one antenna. So why would some of these access points have two? Well, what would happen is an access point could recognize that on one of those antenna, it was receiving signal and it had poor reception, possibly due to, in fact, these multipath issues that where we had these different forms that would hit the same signal or hit the same antenna, but at different delayed periods, which then muddies the signal. Remember, multipath in and of itself on a particular antenna can cause you to receive the same signal multiple times, degrading the quality of the signal. Bad news. So let's say this one is only getting a signal strength of 30% due to these multipath errors. Right? So there's static on the network. Now we see over here, we've got this other antenna, antenna 1, and that one is able to receive the signal with a better degree of reception because it's receiving this straight shot connection here, and it is not receiving the other multipath signals that are coming in at a different angle, and therefore, right, those are missing. All right, those are missing that antenna. They're not hitting it and causing the same issue. Therefore, I get great signal. So this guy's got, let's say, 85% signal strength. Doing pretty good, right? From a greater distance, you're going to experience more of these issues, and therefore 85% is actually pretty great. So what that access point will do is recognize that this particular client, whenever it's receiving frames for this particular client, it's going to only bother processing them from this antenna, right? Antenna number 1. So it creates a short-term binding of this client to this antenna. Now, it's based upon receipt of that signal. The access point recognizes the receipt of the signal over different antenna. Which of those antenna receives it better? That's the one we're going to use for that client. That same antenna then de facto becomes the transmission antenna to send that content back. It's not going to. That's going to be the tool that it uses in order to create that association. Assumably, it'll have the best path in reverse. We don't really know that. It may not be true, but it has to do something, and so this is the algorithm that it uses. In order for this to function, in order for diversity of antenna, having multiple antenna and then creating this per client association to function correctly, keep in mind that the access points to antenna must be serving the same area, right? So we don't have one antenna serving one network and another serving another. It's got to serve the same network. And in fact, those antenna must be the same. We got to compare apples to apples here in terms of receiving signal. And so the only way it can do that is 2 of the equal antenna on the access point serving the same area. Great. Now we can compare the signals, choose the best one, and create a good binding for that particular client. And then when a different client shows up, right, we got another laptop over here, its path may end up using the other antenna. Great. That ends up with better processing of the actual network, better bandwidth utilization. We're able to utilize those antennas more powerfully.